what I want you guys to understand, when you're solving a lot of the problems in geometry, you might develop one equation that isn't really nice to solve. So then you try to use the information, the picture information throughout the question to create a second equation. Maybe that one is a little bit easier to solve, but you still have trouble with it. Maybe there's enough relationships in there you can find a third equation that was easy to solve, and then that one maybe provides you insight on how to find and solve the other two equations that you already set up. Okay? And then that's kind of what happens in these questions. The one yesterday, we kind of looked at something like this. We said, those two angles there, what's the relation between those two angles? They're supplementary. They're a linear pair, so they should add up to 180. So I'm going to write that equation. Say 5y plus 4x equals 180. Okay? Now, that equation for us right now is problematic because it's got two variables in it, right? We would love this equation just to be like something like 4x equals 180, or maybe just like 5 plus 4x equals 180. But because of that additional y, that equation becomes, right now, impossible for us to solve and gain a numerical value. Okay? What we can do, I'm not saying do this, but you could do this. And you worked a little bit in algebra doing this stuff last year. I'd go 180 minus 5y. And I could say x then equals 45 minus 5/4 y. Okay? I can solve for x. Okay? But what happens when I solve for x is that I still end up with an expression over here in terms of y. Does that make sense? Okay? I didn't get one concrete numerical value back. So, and a lot of the problems that we do in this class, when we get an equation that has two variables in it, you end up needing a second relationship. Okay? So I'm going to look at my problem, and I'm going to look at those two angles. Okay? What's the relationship between those two angles? They're supplementary as well. Okay? So when I add those together, I get 4x plus x plus y plus 102 equals 180. Okay? Now what's real nice about that is that it's got the same exact two variables that the blue one had, right? And that's what we need when we want to solve an equation that has two variables. We need an additional equation that has the same two variables. If you remember from last year, that was referred to as a system of equations. Okay? System of equations. And I understand because you've got 1 year of algebra under your belt that maybe you're not all that in tune and great at solving system equations. So we'll spend some time on doing this, but it becomes a technique that is used throughout all mathematics. Okay? It is extremely common to see systems of equations inside other concepts. Okay? And so it is a tool that we should learn how to kind of refine and be able to use. Now, what I suggest, and because you could have seen this in a couple questions yesterday, I don't think it happens in this one, but I'm going to look at one more relationship, because there should be something here, right? What do we know about those two angles? What type of angles are they? Vertical, and they should be congruent. Okay, so I'm going to say 5y equals x plus y plus 102. Okay, and that gives us three equations. Equation 1, equation 2, and equation 3. Okay, and because we use the same exact angles and the same exact x and y's, if I'm able to solve one of these equations and find a numerical value for x, then that's the numerical value for x in all of the equations. Does that make sense? So yesterday we saw an example where this one here, the vertical angles, okay, that was able to be solved for. It's a really easy equation that had one variable. We were able to solve for x. That meant that in any one of these equations, I could have plugged in x. Okay, that value of x, and then left with y and solved for y. Okay. The reason I write all the equations that I can come up with, all the relationships I can come up with, is because I want to make sure that I I think about the math that I'm doing. I think about the algebra that I'm going to do. Because I don't want to blindly just set equation 1 and equation 2 and start doing the system equation work with those, when there would have been an equation 3 that would have gotten me to the answer 10 times faster. Does that make sense? Okay. I think a huge component of math is not only being able to do the arithmetic, but to know why and when to do an appropriate type of arithmetic, but also be efficient. Okay? Don't waste your time on something. If the problem could take 5 minutes and you waste your time and take 20 minutes on it. Okay? So that's why I developed this third equation. Ultimately, I don't need that third equation. Okay? Because it didn't help me solve directly for x or directly for y. When we have an equation with two variables, we need another equation that has the exact same two variables. Okay? So right now we've got three equations with those two variables, x and y, right? You can choose, and we can do this to show that this works, but you can just choose any two of those equations. Doesn't matter which two. The blue one and the red one. Maybe you want to take the blue one and the green one. Maybe you want to take the red one and the green one. Okay? Those are your options. It does not matter. Okay? You will solve x and y for the same amount, same values, regardless of two equations you take. I'm going to use the blue one because it's set up real nice the way it's developed. Okay, so take the blue one, write it down. Now we're going to take either the red one or the green one. I'm just going to take the red one because it's the second one. And I'm going to try to rewrite it so that it's in the same exact format as the blue one. So I have the y's and the x's on the same side, and then my constant value on the right-hand side. Okay, so when I do that, I'm going to rearrange some stuff here. Those two things are going to be 5x, right? So I'm going to put that so it lines up with the x's from the blue equation. Okay. This y is a 1y, so I'm going to line that up underneath the 5, the 1y. The 5x was a positive, so I know that should be a plus sign. And now I'm going to take this 102. I'll move it over to that side. It should give me 78. Okay? So that's kind of the task. That's the goal when we first see these types of problems. Okay? The hope is, we've seen this before, when we have two equations and two variables, basically what we do is we write them in what we call standard form. Standard form from last year, it was like you had your x's and y's on the left-hand side like we have here, equal to your constant on the right-hand side. Ms. Coles probably wrote it this way, like ax plus by equals some constant c. That's standard form. I don't wrote it. Standard form says your x comes first, and it's got to be positive coefficient, that kind of stuff. But it doesn't really matter for what we're doing. As long as x and y are on the left-hand side, your constant on the right-hand side, you set yourself up to do this problem pretty easily. Okay? What we want is to be able to add straight down. I want to add these columns. I want to add the green column. I want to add the blue column. And I want to add the yellow column. Okay? But the goal to add those down is that when I add my y's together, they go to 0y. Or when I add my x together, they go to 0x. Okay? Probably 99% of the time, you're not going to get both of them to go to 0y and 0x. You want one of them to go to 0y, and the other one will be like a 2x or something like that. Or you'll get like 0x and a 3y left there. But what happens, what's 0 times x? 0, right? So your x variable will disappear. And 0 times y is 0, so your y variable could disappear. Okay? If I add them straight down right now, that's not going to happen, right? Okay? So what I need to do, you talked about this last year, you can alter these equations by anything you want to. Okay? Through multiplication. All right? So all I have to do is I have to pick a variable that I want to cancel out. Okay? And I try to make it pair up with the coefficient of the variable above it, and make sure that they're opposites. So right now I think these two are going to be the ones that I want to pick out. One of them is 5. Okay, I want to take this one and turn it into a negative 5. That makes sense? Well, the only way I can do that is through multiplication. Okay? And you can multiply by anything you want to. You can multiply by whole numbers or integers. You can multiply by fractions, whatever you want to multiply by. Okay? So I'll multiply by -5. And that's going to take that bottom equation. It's going to change it to -5y minus 25x equals, what's 80 times 5? 400, right? Okay, so 80 times 5 would be 400. Okay? But I went 2 times 5 too many, right? Okay, so it's 2 times 5. 10, right? Okay. So should that give me -390? Okay. So this equation here, 1y plus 5x equals 78, is the exact same thing as -5y minus 25x equals -390. It provides me the same exact, the same results. Okay. Now I'm going to take the top equation, just rewrite it over here. I'm not going to change it at all. And now I'm going to add straight down. Add straight down, those go away. Gives me 0y. When 0 times y is 0. Now I get -21x equals now, when I add these together, to give me -210. Now is that an equation that's really easy to solve? And that's the hope, is that when we do this correctly, we get down to a one-step equation. And we got a one-step equation here, divide both sides by 21 or -21. I get x to be 10. Solve for x. Now I know it's 10. And now the task is to find y. Okay? Well, what's nice is that as long as the equations that I have created throughout the entire problem are true, I can plug x back in any one of them and find y. So I can plug into either one of these equations to find y. I can plug into either one of these or any of these three up here. I think that one's probably going to be the easiest one, the most simplistic looking, I think. So I'm going to go 5y plus now 4x becomes 10 equals 180. Well, 4 times 10 is 40, right? So I'll move that 40 over to 140. Okay. How many times does 5 go into 40? 8. It goes into 120 times, right? So y should be 28. So x is 10 and y is 28. And we can come back up to our picture to plug that stuff in, and it should make sense. Okay. 5 times 28. Okay, 5 times 28 should give me 140. 4 times 10 should give me 40. Isn't that the relationship that we said should exist between those two angles? It should be supplementary. And 140 and 40 is supplementary. You can do the same thing here, x plus y. So there's 38 plus 102. That's 140 again there, right? Are those two angles then there supplementary? And if that angle is 140 here, are we seeing that this one here was also 140? Which is that equality statement, congruency statement that we use in vertical line. Okay. So that's one way of doing that problem. But you can have basically an infinite number of ways of doing this problem based on what equations you choose of those three, and then based on what variable you want to cancel out and what you want to multiply your respective equations by. So let's say I use that blue equation again, 5y plus 4x equals 180, but now I use the green one as well. So I'm going to rewrite the green one so that it's 5y. Okay. Actually, it's going to be, so I got to move this y over here, right? So it's going to be 4y. Okay. I'm going to move that x over here as well, so it's going to be minus x. And I will leave the 102 on the right-hand side, so it becomes positive 102. Okay. So I just combine like terms, and I move things across the equal sign using opposite operations. And now my goal is to add those straight down, and hopefully maybe something cancels out. We realize that nothing's going to cancel out, but what variable would it be really easy to cancel here? Cancel the x's. I could make I can make this 1 right here a 4 pretty easily, can I? Okay. And the way we determine that is look at those two. Can I make a 5 into a 4 very easily? Now, the only way I can take through multiplication, the only way I can make a 5 go to 4 is if I multiply by 4/5. That means I can multiply 5 by 4/5, I can multiply 4 by 4/5, I can multiply 180 by 4/5. Do we like to multiply by fractions like that? It's going to get real nasty, okay? So if I wanted to cancel y's, it's the same idea with 4 making it turn into 5 and multiply by 5/4. Now to multiply everything, -1 and 1 and 2 by 5/4. The only way that we would maybe logically want to change the y's is change them both to 20. Does that make sense? Make one positive 20, make the top one positive 20 by multiplying by 4, make the bottom one negative 20 by multiplying by -5, right? But then we got to change both equations, and that's more work than necessary. But it will work. It will get you an answer. But I think looking and trying to decide before I just blindly start doing stuff, it might make more sense to analyze the problem a little bit and start to foreshadow. It's okay, if I do it this way, it's going to be this amount of work. If I do it this way, it's going to be more work. So maybe figure out which one's going to be easier, the least amount of work. So I'll multiply this 1 by 4. So that's going to give me 16y minus 4x equals 408. Okay, the only thing I pay attention to is a lot of people forget to multiply the other side, the right-hand side by 4. And we'll write like 16y minus 4 equals 102. And that messes everything up. I'm going to put the blue one on top of it, 5y plus 4x equals 180. And now I'm going to add straight down. So adding straight down gives me 21y. The x's cancel each other out. Okay. Now I'm going to get, 588. Okay. Well, 21 goes into 588 28 times. So y equals 28. Is that the same 28 that we got using other equations? Yeah. Okay. If I plug that back in, friends, if I plug that back in right there, 5 times 28 plus 4x equals 180. Okay, well, 5 times 28 is 140 plus 4x equals 180. Subtract 140 from both sides, you get 4x equals 40. X still ends up being 10 that we found using other equations. So my hope is that you guys realize in this course, and really beyond this course, when you're presented with an issue, with a problem, there might be 5, 6, 7, 10, 20 different ways of doing it. And that's the problem. If there's 15 different ways to do a problem, is that kind of, we can do it one way, or everybody can do it 2 ways. It's kind of silly to talk about the other 16, 17, 18 ways to do it. Wastes a little bit of time, right? But what I want you to understand with the system equation stuff is that it's not going to go away. It's going to be something we talk about quite a bit in this class. We use quite a bit in this class. So, in the event that you struggle with this, hey, I remember system equations last year vaguely. I'm really not all that good at it. You can go to the webpage and scroll to the bottom. Okay, and right here it says system equations, and there is a wide collection of videos there to walk you through how to do a system equation. Okay, because what happens, and I see this all the time through past courses, is the geometry is not something that we struggle with. Okay, the hope is that we all recognize that we can set up that equation, right? 5y plus 4x equals 1. You can see that. And you can set that equation up. You've done the geometry. Okay? But it's the algebra that we struggle with. Okay? So if you struggle with the algebra, use those videos. Okay? It might take, watching 2 or 3 or 4 of those videos, or 2 tonight, 2 tomorrow night, and do the practicing of the problems that are in those videos to help you kind of refine that skill. Okay. I wish I could teach algebra at the same time teach geometry, but it's not logistical, it's not feasible to be able to do that. Okay. So you will have to do a little bit of extra on your own if you're struggling with that stuff. Now we'll talk about it in class and work with them, but we can't talk about it as much as we would have if I was teaching algebra. There's also going to be eventually some factoring that was a huge component of last year. And if you struggle with factoring, click on that link again, and you've got, I don't know, there's probably at least 20 videos there, hundreds of examples inside there. Even on the factoring one, you can click this, and there's going to be a bunch of practice problems, interactive practice problems that you can work with factoring. And that's the thing about math. After you get through Algebra 1 and Algebra 2 for the most part, all your courses after that, understand or realize that you have that algebra background, and they can go, in one section, whatever content you're talking about, one might use factoring to explain that content or to provide a problem in that area. And the next one might have system equation. The next one might have a square root equation. The next one might have absolute value. And they ping pong back and forth between the types of equations that you might get, so you can practice and use that algebra. Does that make sense? All right. So please understand that if we can get the geometry, that's the number one test. That's the number one goal. But then hopefully get to the point where we can solve these equations using our algebra skills. If at any point we're going through something like system equations, like I said, there's so many ways of doing that. If you did it a particular way and you want to see where you went wrong, tell me, hey, I did it this way. Can you do it the same way I did it? Okay? Or can you follow this line of thought to get there? And by all means, we'll do that. I just want to show you, kind of give you a visual of that exact same type of problem, but how it might benefit you to think about what you're doing before you actually start doing it. I think it's question 10. Okay, really the same setup, but if I start writing my equations, okay, I always look at it's just the way I'm programmed. My eyes always go straight to linear pairs. I don't know why, but it's just what I see. So I go, those two things should give me what? 6x plus y equals 180. Okay, so instantly I see the two variables, and I instantly think I need another equation that has the same two variables. And that's what you need to start programming yourself to do. So then I look, okay, there's another relation. Well, I see another pair of supplementary angles there, another linear pair. So add those together, and I get 2y minus x plus x gives me what? If I add the plus x and the minus x, they go away, don't they? So it gives me 2y equals 180. Okay. And my third equation would have been the vertical angles again, so 5x equals 2y minus x. Okay. If I look at those three equations, and I write them all down, if I look at that red one, I thought, oh, I'm going to need another equation that has the same two variables. But then I look at the blue one it does what for me? I can solve for y right away, can't I? Y's got to be 90 now, doesn't it? And that y then is the same everywhere else. I guess it's 3y, isn't it? 3y. So y would be 60. Okay? So we got 3y equals 180. But then everywhere else I see y, either in the red equation or the green equation, that y is that 60. Okay? And I can plug that in and substitute. And now if I substitute it, I get 6x plus 60 is equal to 180. Is that a much easier equation to solve than look at the red one and the green one together using 180? Okay. So that's the hope that we realize, is that when you start writing equations, if there's multiple ways of doing it, solving the problem, think about those ways. Okay? Analyze. It might take 10, 15 extra seconds to think about it. Okay? Well, I'd rather take that 10, 15 extra seconds to think about what I'm doing and why I'm doing it, in contrast to just blindly being robotic, going through a problem, and it taking me 15 minutes to do that problem, when it really could have taken me maybe 2 minutes. Okay? And that's something you'll think about on the ACT. The ACT does teach you or I guess not teach you, but test you on your math abilities and your reading abilities and all that kind of stuff. But it also teaches you to, or I guess test you on your test-taking abilities and strategies. And you recognize, okay, I've got 60 minutes to do 60 questions. I can't waste a bunch of time on these easy questions. I can't do it long. I gotta have these, understand these tricks and analyze the problem a little bit before I actually go through and blindly do the problem. Because I might waste 5 minutes. The problem is really designed to be a 30-second question. Okay? But if I can start saving those extra minutes on the easy questions now towards the end of the test where it gets hard, I now have a bank of time and I can have 20 minutes left over to do 2 questions. That would be nice to have. Okay. So think those things through as we go through some of these problems. You guys have anything else? Those were the bulk of questions that I had throughout yesterday about 2.6 and 2.6 day 2. Something also came up. Like, if you guys are looking at it, it's good that you're recognizing this. Like the homework questions, let's pull one up real quick. Like that says 2.7.35, right? So people are seeing that right away, saying, we didn't do 2.7. I'm not going to do that question. 2.7, and it's got that asterisk beside it, that is coming from another textbook, okay? And in that other textbook, their 2.6 was 2.7. Does that make sense? Okay? So if there's an asterisk next to any question, they came from another textbook. So it looks like a lot of these came from the other textbooks. You see this one's 2.6. No asterisk, right? So that comes from the textbook this course is designed around. And a lot of pick from math had something, a lot to pick out 20 questions from other textbooks per assignment. And to be honest with you, the other textbooks are a little bit better. Remember, test tomorrow. If we